All right, so welcome back again. And in this lecture, we will do everything what we did in last lecture using the variable method. And also we will do a little bit extra. We will look at the difference between the constant method and the variable method. Also, we will know more about the shapes. We will understand more about shape. Okay, so we can do everything actually, as I already mentioned. We can declare one scalar, vector, matrix, and tensors using the variable methods. So let's create one scalar first. Let's name the variable scalar and assign the scalar value using the variable method. And first of all, we have to import TensorFlow. Import TensorFlow. And as we already discussed that we can either create an alias or not, that's up to us actually. We create an alias because it makes us easy to write codes. Like instead of writing TensorFlow every time, we can write tf every time, and we can say tf.variable with capital V, and here we can pass any scalar value actually. Let's pass 99. Execute it and print it using the Python's print function. And we can see for the first time it's a variable object, not a tensor object. And as usual, the value and data type and shape. So these are none to us. Shape is none or shape is 0. We can check it using scalar dot shape. We can see empty shape because it's a scalar value. We know scalar does not have any shape. And now let's create something which has shapes. Let's create one vector. In previous 2 lectures, we have already known and practiced what is scalar, vector, matrix, and tensor. So now simply let's create a vector using the variable method. tf.variable, create a vector. Assign it in a variable and check the vector. We can see its shape, its data type, and the value. As usual, we can change the data type if we want using the dtype property. We can make it float, check it, and we can see data type is float 32. What about the dimensions? Okay, when we create any scalar or vector or matrix or tensor using the variable method, then we have to use the rank method of TensorFlow to check its rank or a dimension. So we can say tf dot rank, and here we can pass our vector, and we can see our rank or dimension is 1. Now let's create one matrix, and here tf dot variable method, and inside the method we will create the matrix. So here we can say in a different way what we said in our previous lecture. So we can say there will be an array. For matrix, there will be an array, and inside the array there will be multiple arrays. These are the inside arrays, and this is the outside array, and the value will be only inside array, only inside of inside array actually. So 2, 3, 4, 5. 11, 22, 33, 44. So its array inside array. Execute it. Check the matrix and check its shape. We can already see its shape is 3 by 4, which means 12 elements. So 3 multiplied by 4, 12 elements. So check the shape using the shape property, matrix dot shape, and we can check the size using the tf.size method, and we can check its dimension or rank using the rank method of TensorFlow. We can see the two-dimension matrix or two-dimension array, which already we have seen one array at the beginning or at the top, and there are multiple sets of array. So arrays inside one array. Now let's create tensor. Tensor equal to tf.variable. This is one array, and inside the array there will be another array, and inside this array there will be another sets of arrays. There can be one array or two array or three array, but these arrays will carry values. So array 1 2 3 4 5. Okay, let's skip 4. So array of values, or we can say array which is holding elements, will go inside one array, and that array will be inside another array. And in the same way, this array which is having set of arrays with values can be duplicate. I mean, can be repeated. I mean, can be multiple. So we are saying there will be one array. Inside that array, there will be another array. Inside that array, there will be another array. And this array will carry values or elements. So, one dimension, two dimension, three dimension, and then value. I hope you understand how shape is going and how dimension is going. For shape, let's check the shape first, then we will discuss again. So execute it. Check the tensor, and we can see 2 by 2 by 4, which means there will be 16 elements. So let's check the size dot size and tensor, and we can see 16 elements. What about rank? We can see, so array, this is one dimension. Inside this array there is another array, so this is another dimension. Inside this array there is another array, so there is another dimension. One dimension, two dimension, three dimension. So we will count before value. Our value is here, and before that we will count one array or one square bracket. So one dimension, another one, two dimension. So rank must be 3. And we can see our rank is 3. Now let's understand shape again. So we can see 2 by 2 by 4. In our previous lecture, we discussed in this way: element and number of rows and number of sets. In this lecture, we will understand from left side, not from right side. So this is our main array. We will not count main array while we are counting the shapes. We will always escape the first array or first square bracket. After that, we will start counting. So after first square bracket, there is one array and two array. So this is 2. And inside the second array, there is one array and there is another array, so it's 2. And then there are 4 elements in every array. In every array means array which are holding data, so that's 4. So if we increase any of them, like we are increasing this array which is carrying or holding value and making it 3, so array, there is another array which is having 3 set of arrays, and then again another array, and it's also having 3 sets of arrays. So now our shape should be 2, as our first array has 2 sets of arrays, then 3, as every of these arrays have 3 sets of arrays, and then 4, because every array has 4 elements. So execute it and check it, and we can see 2, because we have 2 arrays inside first array. As we know, the first array will not be counted, so it's counting these 2, and 3, these 2 arrays, each one of them are having 3 arrays inside it. So this is 3 and 4 is elements, you know. What if we increase the number of this array? Now we have 3 arrays, 2 and 3 arrays inside our main array. So our shape will be 3, 3 and 4. 3, 3 and 4. So how many elements, or what will be the size of this tensor? 3 into 3 is 9. 9 into 4 is 36. So the size of this tensor will be 36. Let's check it. 36. And what is the rank? As usual, rank is 3, because there are 3 closing square brackets, or we can say there are 3 opening square brackets, or we can say inside main array there is another array, so it's second. Inside the second array there is another array which is actually carrying the values or holding the value, so dimension is 1, 2, 3. So dimension or rank will be 3, and we can see it's 3. So at this stage you may have one question in your mind. We are doing everything point to point, same what we did in constant, using the constant method. So why do we need to use the variable? Let's create one vector using constant method again. So constant vector tf dot constant one vector, print the vector. We can see the value. Now what if we need to change any element of this vector, of this constant vector? Can we do that? Let's try that. Let's say we want to change the first element, so index 0, and instead of 1 we want to make it 11, and execute it, and we are getting an error. It's saying object does not support item assignment. Using the constant method, if we create any scalar, vector, matrix or tensor, we cannot reassign values here. What about the scalar or matrix or vector what we have created using a variable method? Let's check it. So our vector, okay, we have this value. So let's print it first. You can see these values here. Now vector index 0 assign, instead of 12 let's do 1 2 3. It's also saying the same thing. Object does not support item assignment. Then how can we assign new value here? We can do that easily using the assign method. So we can say vector dot, okay, vector index 0 dot assign. We can say 1 2 3, and it's working and it's changed. What about the constant method? Because we did not use assign method. So constant vector dot, okay, index 0 and make it 1 1 1, okay, not directly using the assign method. Okay, now it makes sense. There is no way we can assign new value at the same position, which means there is no way to reassign value using constant method. It means if we create any tensor or matrix using the constant method, then we can never reassign values. But if we do create any vector or matrix or tensor using the variable method, then we can reassign values. That's all for now. To subscribe the channel, hit the bell icon, give a thumbs up, leave some great comments, and share the videos with your friends. See you soon. Bye for now.